Okay, so on this topic buster, we're looking at expanding and factorizing. Yes, it's algebra, but it'll be fun. Enjoy! Okay, so for some of you, algebra is the best thing since sliced bread. However, I also know for a lot of you, algebra is where you kind of switch off. Expanding and factorizing is going to come up on your exam. So whether you like it, whether you dislike it, you've got to learn it. And actually, there's only so many questions they can ask. And I will cover almost all of the types of question they can throw at you at grade 4, grade 5 on expanding and factorizing. There are two different types. There is linear equations and linear expansions and factorizing, and we will touch on quadratic expansions and quadratic factorizing, which is maybe a bit more difficult. Something you will need for the video is to understand that 3 times x is 3x, that x times x makes an x squared, but an x plus x makes a 2x. Now, before we get started, I want you to think about if you were to do a calculation such as, 23 times 3, right? You would break up that 23 into a 20 and a 3, and you would do 20 times 3 and 3 times 3. Then you'd add those together. You've done it ever since you started multiplying large numbers together. So remember way back when you did the 12 times tables. Anything beyond that, you then split the number up into 2. Some of you do it with grids, these sort of square things. Some of you do it through columns, but essentially you're all doing the same thing. This is no different, but instead of 20 plus 3, we've got x plus 3. That's the only difference. There is nothing other than that fact there's a letter there, and a letter represents a number, we just don't know what it is. Okay? So all you need to do for this video is just learn the methods of doing expansions and factorizing. Repeat them, practice them. Okay? I hope you enjoy it, and good luck. Okay, so first of all, we're going to try and find the common factors of a couple of numbers or expressions. So the first two we've got are 14 and 21. Now, I know that 14 is 2 times 7, so it's got 2 and a 7 in it. I know that 21 is 3 times 7, and looking at that, we've got a 7 here and a 7 here. So the common factor that we've got is 7. Now, we've got 2x squared, so 2x squared, and that is 2 times x times x, and we've got 3x. Now 3x is just 3 times x. Okay, so let's have a look and see what we've got. Well, the 2 and the 3, well, they're not the same, but we do have an x here. Okay, so the common factor is that x. And we've got on the next one 10a squared, which is 10 times a times a, and we've got 15a, which is 15 times a, but that 10 is 2 times 5, so it's 2 times 5 times a, and that 15 is 3 times 5 times the a. So we've actually got the a and the 5. So our common factor is 5a. Okay, have a go yourself. So the first one, 12 and 16, Well, I know the biggest times table that they're both in is the 4 times table, because 3 times 4 is 12 and 4 times 4 is 16. This next one, the 4 and the 3, well, there's no number that goes into 4 and 3. Okay, 4 is 2 times 2, but 3 is just 1 times 3, it's a prime number. But the y squared is y times y, and the y on its own, well, they would make a common factor of y. Last one, okay, it's no surprise, this is a number and a letter. 20 and 10 are both in the 10 times table. And c squared and c, well, we can divide out as c, they both have c in them. And that's our answers. Okay, so now we move on to expanding. Now, expand is a posh way of saying multiply out brackets. So we've got a set of brackets, we need to get rid of them. And the way I do this is called smiles and rainbows. However, you might do a different method. If you do it a different method, stick with that method as long as you get the same answer as me. Smiles and rainbows mean that whatever's on the outside, on this first one it's the m, I'm going to times by the first number on the inside, and then I'm going to times it by the second number on the inside. And I always just do a little line here to remind me to times it. So I'm going to do m times 2m first. Now, m times 2m, well, I've got two m's timesing together, so that will give me 2m squared. Okay. And then I'm going to do the rainbow, which is m times positive 3, which is going to be positive 3m. Now, that might not look like an answer, but that absolutely is the answer. So you would write 2m squared plus 3m. Now, this second question is a lot harder. Well, actually, it's the same thing. We just got to do it twice. There is a gotcha with this. We'll get to that in a second. So, smiles and rainbows. I'll do that little time sign to remind me to times it. And let's just tackle this bracket first. So 3 times 5x is going to be 15x. We're doing 3 times positive 2, so that's going to be positive 6. Okay, let's try this. Now, what we're doing there with that smile is negative 2 times 3x. And what we're doing in the rainbow here is negative 2 times 2. So let's do the first one first. Minus 2 times 3x. That's a negative times a positive, so it's going to give us a negative. And 2 times 3, which is 6. And it's a 3x. Well, there's no other x's there, so it's just going to be x on the end there. Okay, the rainbow is negative 2 times positive 2. So that will also give us a negative. And then 2 times 2, which is 4. Now, another word you'll get with this question is simplify. So it will say expand and simplify. The simplify bit is because we've got x's that can add together, and we've got numbers that can add together. So let's do the x's first. 15x take away 6x is going to be 9x. Positive 6 take away 4 is going to be positive 2. And then that's it. Right, this last one. Now, with this last one, we've got two items that want to times out the bracket. They want to do smiles and rainbows, both of them. We've got this x and we've got this positive 3. They both want to multiply out their x plus 4 bracket. Now, they can't do it at the same time. Okay, there's no way of doing that. So they've got to take turns. So the first thing we do is we let the x, this x here, times out the bracket. So we let that have its go. X plus 4. Then we let that plus 3 have a go. So it can multiply out the bracket. Okay. So with the previous questions, we've had one number before the bracket. Now we've got two. We've got the x and we've got the positive 3. So let's do the x first. I'll do that little line to remind me. X times x is x squared. Okay, x times 4 is plus 4x. Okay, let's do a smile rainbow for the next one. Positive 3 times x is plus 3x. Positive 3 times positive 4 is positive 12. Now, almost every time, the middle two here will be able to be simplified. So nothing will simplify with that x squared. Nothing will simplify with that plus 12. But the 4x plus 3x is going to be 7x. And that's our answer. Okay, have a go yourself. Okay, so this first one, let's do our smiles and rainbows. We've got 3e squared, because e times 3e, and e times 4, which is just 4e. Next one, we've got smiles and rainbows there. We've got smiles and rainbows there. So we've got 2 times 3d, which is 6d. 2 times 2, which is 4. Then we've got minus 4 times d, which is minus 4d. And then minus 4 times 2, which is going to be minus 8. 6d take away 4d, which is 2d. Now we've got a slightly harder one here. We've got plus 4 take away 8. Using your number line, go to 4, jump left 8. And you end up at minus 4. And that's our answer. Right, this last one, we're going to rewrite this. So the x is going to first of all have its go, this x here, to expand with the x plus 5. And then the 2 there is going to have a go expanding the x plus 5. Okay, so let's get our smiles and rainbows in. Okay, so x times x, which is x squared, x times 5, which is 5x, 2 times x, which is plus 2x, and 2 times 5, which is plus 10. Then we've got these two middle ones here that add together, so we have x squared plus 7x plus 10, which is our answer. Okay, so you are probably used to doing inverse functions, even if you don't know what they are. So when you learn add, you then learn to take away. When you learn times, you then learn divide. When you did squared, you then learn square root. It's the same with expanding. We break out the brackets with expand, and the inverse or opposite of that is factorize. And factorize, all it means is put it into a bracket, or maybe in the next example we'll do 2 brackets. But for these ones we're just looking at 1. Okay, so this first one, 6x plus 8. I always start these off by putting a set of brackets down. Okay, simple. Set of brackets, remind me, right, factorize, I'll need a set of brackets. Now, I am looking for the highest common factor of 6x and 18. Now, I know it's not going to be a letter because there's only an x and 6x. So I'm looking at the numbers, 6 and 18. What is the highest times table they're both in? Well, they're both in the 6 times table. So 6 will be on the outside of the bracket. The next thing I ask myself is, right, what do I have to times by 6 to get to the 6x there? 6 times, well, x. Then I ask myself, what do I times the 6 by to get to the 18? 6 times 3 is 18. So our final factorized expression is 6 brackets x plus 3, and then that's the answer. However, what we could do to check is expand it and see if it works. So let's just check. 6 times x is 6x. 6 times 3 is 18. We know it's right. You leave the exam knowing you've got the answer right. Okay, let's have a look at the next one. So first thing I do is put a set of brackets down. Okay, we've got y squared and we've got a negative 5y. Well, the y squared has no number, so there's not going to be a number on the outside of the brackets. They both have a y that they can give. So I'm going to put a y on the outside. Next thing I ask myself is, right, what do I times y by to get to y squared? Y times, well, y. Not y, but like the letter y. Okay. Next thing I ask myself is, what do I times y by to get to this negative 5y? Well, it's going to be a negative. Oh, helps if I have the right colour. It's going to be a negative. And, well, just negative 5. Minus 5 times y is minus 5y. Again, I'm going to check my answer here. So what we've got y times y, which is y squared, and y times minus 5, which is minus 5y. Well, that's my answer, so I know that that's right. Okay, remember each time this is your answer here. Okay, last one. So we know this is going to be a harder one. Okay, let's get the brackets down. So this time it looks like we've got maybe a number and a letter. Okay, let's deal with the numbers first. 18 and 27. Well, they look familiar because they're both in the 9 times table. So it's going to be 9 on the outside. But we also have an f squared and an f. So I know that I'll be able to divide out an f. Okay. So 9f times what? What do I times that by to get to this 18f squared? Well, I know 9 times 2 is 18. And I know f times f is f squared. So it's going to be 2f. Ask myself the second question. How do I get from the 9f to this 27f? Right, so 9 times 3 is 27. And, well, 9f times 3 will be 27f. Let's do our last step. Let's check this. So we're going to do the 9f times 2f. Well, 9 times 2 is 18. F times f is f squared. Okay, we've got 9 times 3 is 27. And so we've got that f as well, because it's 9f. And let's have a look, let's compare it, and that is the same. So we know that that is the correct answer. Okay, have a go yourself. Okay, so let's put the bracket down for this first one. We've got 721, so that's going to be 7. 7 times x is 7x. And 7 times 3 is 21. Okay, next one. Put a set of brackets down first. Okay, we've got, well, a 2 and a 3. There's no numbers that we're going to find. But there's definitely an e we can divide out of both of those. So what do I times e by to get to 2e squared? Well, there's going to be a 2 there and an e there to get the e squared. Minus, well, what do I times e by to get to negative 3e? Minus 3. Okay, and the last one. So we know there's going to be a number and a letter. 8 and 12, well, biggest number we can divide out both of those is 4. K squared and k, that's going to be a k. 4k times what is 8k squared? So I need to have a 2 there to get the 8 and a k there to get the k squared. 4k times what is 12k? So it's going to be a 3. 4k times 3 is 12k. Okay, so this is quite an advanced section now. We're looking at factorizing quadratics. This used to be on just the higher paper. However, times have moved forward and we have put this on both papers now. So this first one says factorize that. Now that is called a quadratic. It has an x squared, it has an x, and it's got a number. Okay. The difference with these ones is instead of one bracket, we know it's going to be 2. In fact, as soon as I see that, I always put down 2 sets of brackets. It's the x squared that gives it away. Okay, now you might say, hang on, a lot of the other ones from the previous ones had an x squared on it. Yeah, exactly. This is where the problems come in. It has to have an x squared and a number. Okay, x squared and a number. So that x squared and the 12 at the end. Okay, that's the difference, is that number at the end. Anyway, first things in the brackets are going to give us this x squared. Okay, now for a grade 5, they will always be x or y or whatever letters in it. Okay, there's no coefficients, there's no numbers before the x squared. So the first thing in both the brackets is always just going to be the letter. Okay, now this next bit is a bit weird. Okay, and actually if you remember when we expanded these quadratics, okay, which we did on the previous one, no, 2 ones ago, right, you will remember that we got this number by timesing together the last 2 here. Okay, and we got this number here by adding. Okay, remember when I said expand and simplify? When you simplified it, you added them together. So the question is, what 2 numbers times together to make 12 and add together to make 7? I could try a few out. Well, 12 and 1 times together to make 12, but they add together to make 13, so that's bad. That doesn't work. 6 and 2. 6 times 2 is 12. But 6 plus 2 is 8, so we're not quite there, we're getting closer. But let's try 4 and 3. Well, 4 plus 3 is 7. 4 times 3 is 12, so that works. Now you can check this by doing what we did before. So we do the x first, x plus 3. Then we do the 4. X plus 3, and we'll do this quickly, x squared plus 3x plus 4x plus 12, and then the middle 2 add together to make the 7x I mean. So that becomes x squared plus 7x plus 12, and we know we've got the right answer. Okay, so this here is your completed answer. Okay, now I'm going to make this get difficult quickly, okay? So the second one is much harder. And this -5 here does make it more difficult, okay? Now, we've got a bit of a weird situation here. Now, we're going to do the same thing as we did before. Now, this is an x squared here, which it always is going to be, as I said before. So we know when we put our double brackets down, we're going to have x and x. Okay, but they've got times together to make a positive number, but add together to make a negative. Now we know when we add numbers, if we get a negative answer, one or both of them have to be negative. But we know when we times numbers, if one of them is negative, it will give us a negative answer. So the fact that this is positive and this is negative means that we know that both of the numbers have to be negative. That's the only way that you could get a positive when you times them and a negative when you add them. Now let's have a think. Well, what times what is 6? Well, 6 and 1, -1 plus -6 is going to be -7, so that doesn't work because we need to get -5, don't forget. I think it's going to be 3 and 2. Let's try that. -3 plus -2 is -5. -3 times -2 is +6, so we know that that is correct. Now it doesn't matter which way around that you have these. You could have had x -2 there and x -3 there. It doesn't matter which way around they are. Okay, this last one is a fancy one. You might notice there's no x term. Well, there kind of is an x term. It's plus 0x. Which means when you added the 2 numbers together, you got 0. Now, this is a special case. We do it in the same way as we've done before. You put the 2 sets of brackets down. You put the x at the start. But you need to get 2 numbers that cancel each other out. Well, we know if we add, I don't know, 5 and then -5, we get 0. Okay? This here is not a coincidence that this number is a special type of number. In fact, if I list out the numbers that could be 1, 4, 9, 16, 25, 36, 49, you probably recognise that sequence, which are square numbers. It'll always be a square number for this question. So, what times what is 36? Both of the numbers have to be the same, well, opposite signs, but the same number. It's going to be plus 6 and negative 6. Well, let's try it. Plus 6 take away 6 is 0, hence us not having the x term, and 6 times minus 6 is minus 36. So we know that's correct. Okay, have a go yourself. Okay, so I'm going to start the first one off by putting my double brackets down, and I'm going to put the x at the start of both of the brackets. So we've got two numbers of times together to make 8, well 4 and 2, and add together to make 6. So it's going to be 4 and 2, but it can be in either order. You might write x plus 2, x plus 4, and that's fine too. Right, the next one, I'm going to put the double brackets down. We've got x on the start of both of them. Okay, so we've got two numbers that times together to make a positive, add together to make a negative. So they're both going to be negative. And then 4 and 3. 4, so minus 4 take away 3 is minus 7, so that works perfectly. And minus 4 times minus 3 is positive 12. Okay, the last one. Now this you've just got to remember that it's always going to be x plus a number, x minus a number, and that number will be the square root of that number. So 5 times 5 is 25. So it's going to be x plus 5, x minus 5. Thank you very much for watching the video, and enjoy.